Hello everyone. So today we are going to discuss about the projectile on horizontal plane. So these are the formulas which we are going to use to calculate projection along a horizontal plane. So now let us see some numericals. So let us take first numerical. So in this numerical, a body is projected with a velocity of 30 meter per second at an angle of 60 degree with the horizontal. Find maximum height, time of flight, horizontal range. So in this problem, velocity is given, velocity of projection is given, then the angle of projection is given. So here theta is equals to 60 degree and initial velocity is 30 meter per second. So what you have to find? Maximum height. So you can directly calculate maximum height by using this formula, that is h max is equals to u square sine square theta by 2g. Put value of u here, value of theta here, you will get value of h max. So here we are getting value of h max is equals to 34.44 meter. Now next let us calculate time of flight. This is a formula to calculate time of flight, that is t is equals to 2u sine theta by g. So put value of u and theta here, you will get value of t. So here we are getting t is equals to 5.3 second. Now last is to calculate horizontal range. So formula to calculate horizontal range is r is equals to u square sine 2 theta by g. Put value of u and theta, you will get value of r. So here horizontal range is 79.503 meter. Now let us take another example. So I will just read this question. A projectile is fired from an edge of 150 meter cliff with an initial velocity of 180 meter per second at an angle of 30 degree with the velocity. Find horizontal distance from the gun to the point where the projectile strikes the ground and the greatest elevation above the ground reaches by the projectile. So let us first find out what is given. So here velocity is given, then this distance is given. So this is your point of projection and this is your point of landing. So distance between the point of projection and point of landing is given. So what you have to find? That is range and the maximum height. So here we'll consider first the horizontal motion. So as we learned earlier that the horizontal motion is uniform motion. So here we can use this formula, that is x is equals to vt. So here this is your x, that is range, and the velocity along horizontal direction is your v cos theta. So v is your 180. So 180 cos 30 into t. Now let us consider vertical motion of particle. So here vertical motion is motion under gravity. So let us use this equation, that is equation of kinematics, that is s is equals to ut minus half gt square. Now here your point of projection, or we can say the point of origin, is this, and this point of landing is below this point. Yes, so here we will take s is equals to negative. Okay, so minus 150, here s is minus 150. So initial velocity along vertical direction is your v sine theta. So it is 180 sine theta t minus half gt square. From now resolve this equation. So after resolving this equation, what you will get? From this equation you will get t is equals to 19.89 second. So substitute value of t in equation number 1, you will get value of x. Again you can find out value of x by using alternate method or by using formula of trajectory, that is y is equals to x tan alpha minus gx square upon 2u square cos square alpha. So here y is your vertical distance and x is your horizontal distance. So y, put value of y, x, alpha, you will get value of x, and here we are getting value of x is equals to 3100.54 meters. Okay, now let us see another example. So now in this numerical, a projectile is fired with an initial velocity of 250 meter per second at an target B located 600 meter above the ground A and at a horizontal distance of 3600 meter. Determine value of fired angle alpha. So this is the given problem. Here velocity is given, projectile velocity is given, then distance between point of projection and landing is given, that is 600, and the range is given. Okay, so what do you have to find? You have to find alpha, that is angle of projection. So you can calculate directly this alpha by using trajectory formula. Yes, that is y is equals to x tan alpha minus gx square by 2u square cos square alpha. Put value of y, x, alpha. So you will get this equation. Now to simplify this equation, just divide this whole equation by 600. So after simplifying this, you will get this equation. 1 is equals to 6 tan alpha minus 1.84 in bracket 1 plus tan square alpha. So from this you will get value of alpha. That is alpha is equals to 69.58 and alpha is equals to 29.85. This means that there are two possibilities to hit the target. Now let us see one more type of numerical. Now in this numerical, a pilot flying his bombers at a height of 200 meter with an uniform horizontal velocity of 600 km per hour wanted to strike a target. At what distance from the target he should release the bomb? So what you have to find? The distance, the range you have to find. This you have to find. So just first write down the given terms. So here initial velocity is given. Final velocity is given, that is 600 km per hour. Just convert this kilometer per hour into meter per second. So what you will get? Velocity is equals to 166.67 meter per second. So initially at this point the velocity is equals to 0. Yes. Now let us consider the vertical motion of particle first. So vertical motion, so for that we can use S is equals to ut minus half gt square. So here this is your point of projection and this is your point of landing. So point of landing is below point of projection. So this becomes negative. So here put value of S. So minus 2000 is equals to, here initial velocity is equals to 0. So 0 minus half into 9.81 t square. So from this equation you will get value of t. Now next apply condition of now let us consider horizontal motion of a particle. So here the horizontal motion is uniform motion. So here we can use this formula, that is x is equals to vt. So final velocity into time will give you the range. So here we can say that the bomb should be released at 3365.46 meter to hit the target. Thank you.